Now we could just plug in right away, you know, but it's in all likelihood we can get a prettier form of this. And so this one actually is going to come out to be a reasonably long expression, but we might be able to just, I mean, this is just plain algebra games now to try to get as clean an expression for this force x4 as we can get. And so let me see what I can come up with on that. So we're going to have x4 is equal to g21 t1 over g21 r2 sine theta 2 plus g31 r3 sine theta 3, something like that. And then we're going to have g31 t3 over the same thing, g21 r2 sine theta 2 plus g31 r3 sine theta 3. Okay, and so what I'm doing here, I just split up the fraction that we had there, and the question was, can I make this look any prettier? Just by playing some games with fractions and things like that. And you know, it's still not looking very pretty. And so what I can do with that is I have x4, and I can, I'm going to, like I said, just play some games with the algebra, and I'm going to flip that upside down, this term upside down, and get t1 on the bottom, and the g, if I do the reciprocal, then I can divide through by g21. Okay, and so I'll just have r2 sine theta 2 on top. Now g31 divided by g21 is going to be g32 r3 sine theta 3, something like that. But in order for that to be equal to the thing above it, I've got to take that to the -1 power. Okay. Now this one, I'll do the same kind of game, and I'll have g23 r2 sine theta 2 plus the g31 will cancel when I do the reciprocal, r3 sine theta 3, and all that will be over t3, and it'll be to the -1 power. Okay, now that's not beautiful, but it is something here. And so I could write x4 is equal to t1 over r2 sine theta 2 plus g32 r3 sine theta 3 plus t3 over g23 r2 sine theta 2 plus r3 sine theta 3. Yeah, there's all that algebra. And you know, at this point I can plug in expressions for T1 and T3, and for G32 and G23, though it doesn't simplify much. I mean, it just, what it's going to look like is, here we're going to have T1 is just going to be K1 theta 2 minus theta 2 naught, R2 sine theta 2 plus G32 R3 sine theta 3, and then we'll have plus T3, and we'll have K3 theta 3 minus theta 3 naught, and that's going to be divided by G23 R2 sine theta 2 plus R3 sine theta 3. And honestly, substituting in G32 and G23 doesn't really help the equation, so I'd probably just calculate those separately. And so what that's going to be, the expression for G32 is just G3 1 divided by G21, which is just going to be minus R3 cosine theta 3 divided by sorry, I did that backwards. It's going to be R2 cosine theta 2 divided by minus R3 cosine theta 3, and G23 is just going to be the reciprocal of that, and so that's just going to be minus R3 cosine theta 3 divided by R2 cosine theta 2. And I don't know that the world gets any simpler if I plug in these into those equations, so I would probably just go with 3 equations to capture what's going on with those how the forces work on this thing. Okay. Now, honestly, you get these equations, and there's enough trig things going on here that you almost got to put this in Excel with the kinematic equations. And so you can take a 4-bar spreadsheet or a crank slider spreadsheet to do the kinematics, and then have a column for these X4 values and plug in some numbers. And that's probably the only way you're going to get any insight into what this actually means and what sort of behaviors you can get out of this thing, because quite honestly, you know, there's not a lot of insight that you can get just by staring at the equations with this level of complexity.